Hi everyone, this is Miss Ward. Tonight our notes are going to be on the circular motion unit, concept 3, and we're going to be discussing rolling motion and rolling without slipping. It does get a little complicated, so just stay with me. Okay, so first thing, imagine a bike. Suppose a bike wheel rolls freely. The wheel rotates about its axle, and at the same time, the axle moves in a straight line. What that means is that, not that color. Sorry. Alright, we have a bike wheel. Alright, constantly, the wheel itself is in a circular path. The axle is in the very center. Okay, this axle is moving in a forward direction, in a straight line. Okay, it's moving in a straight line because the bike is moving forward, whilst the wheel is turning constantly. Okay. As a result, the rolling motion of a wheel is a combination of both rotational and linear motion. That part should make sense. The bike itself is actually moving forward while the bike wheel turns itself around. Alright, it's going to get a little heavier now. So the bottom of a rolling wheel is in contact with the ground at some point, right here, right? The forward motion of the axle, which is going this direction, alright, exactly cancels the backward motion of the bottom of the wheel because there is a tangent coming off of the bottom of the wheel moving in the opposite direction. These two forces would cancel each other out. This results in an instantaneous speed of 0 at the bottom of the wheel. So if I have my wheel, the instantaneous speed right here is 0 because it's being canceled with that forward motion up top. Alright, let's get a little heavier. Now, this also means that the top of the wheel has twice the speed of the axle. Okay? Because this is moving this direction, we have this going here, and it's being canceled out. That means that this has to be moving at twice the speed. Okay? Because in order for the overall velocity to be v, the top would have to be 2v. If a car's speed v, as read in the speedometer, the tops of the wheels have the speed 2v. This is to make up for the fact that everything else is being canceled on your wheel. The fact that the bottom of the wheel is instantaneously at rest is what we mean when we say something's rolling without slipping. So because the different forces have to cancel one another out, the very top of the motion of a wheel has to be 2v. Alright? This is when you're assuming that the velocity of the actual thing, the linear velocity, is v. And the fact that the velocity at the very bottom is equal to 0 is what we mean when we say we roll without slipping. Okay, so the deeper end, rolling without slipping is just like walking without slipping. Even though the body moves forward, the soles of the shoes are momentarily at rest every single time they're placed on the ground. So that's why the bottom of the wheels, we consider them to be momentarily at that instant at rest. Alright, so let's look at a quick example. A car whose tires have a radius of 332 centimeters travel down the highway at 25 meters per second, about 55 miles per hour. What is the angular speed of the tires? Okay, so they tell us that the radius of the wheel is 332 centimeters, which is 3.32 meters. They tell you that the velocity it's moving at is 25 meters per second. What is the angular velocity? So calculating it, you take 25 equals 3.32, divide by 3.32, and you get that the angular velocity is 7.53. This, in a sense, would be the speed that the wheel is actually rotating with. Okay? Now, really quickly, before those notes are over, because that's the last bit of your notes, I want to, quickly go over what I was explaining with the wheel, because I feel like maybe I didn't do a very good job when I was explaining it. Okay. So you have your axis here. Right here, there is a backward motion from the spinning wheel. At the same time, there is a forward motion happening at the top. Actually, I'm going to redraw this, making it equal. Okay. Because there is the forward motion, okay, this backward motion cancels out with this forward motion. But we know that overall, the bike has a forward motion because it is moving. So what that means is that instead of if the top motion was V and the bottom motion was V, then this couldn't be V because those cancel each other out. Where is that motion coming from? That's why the motion at the top has to be 2V. So it has to be twice as strong. Because the first piece gets canceled out with the backward motion, leaving us with 1V, which causes this forward motion. These are the same thing. They are equal to one another. This arrow that I've drawn at the top essentially is what causes this yellow arrow to occur. Okay, I hope that was a little more clear. If it's not, I'll go over it in class happily. Alright, make sure you go on, do your online whisk. If you have any questions, please bring them to class. Have a great night.